So Hive basically mimics or gives you a feature of writing SQL-like queries to read or perform operations on these files, giving you like traditional RDBMS style access to all these files, right? So um, basically, underneath what it's actually doing is performing a MapReduce operation when you are doing basic select star or doing a select max on whatever problem you issue through Hive. It's actually doing underlying MapReduce problem. So it's issuing a MapReduce job to the Hadoop cluster, and it does map and then reduce and returns back your results back. So Hive is like a very good querying language. It can also be used with your Spark. So there is in Spark there is something called SQL context and Hive context. You can use either one of them to actually access Hive tables or tables stored on HDFS and try to perform your SQL-like operations. Um, so it's also compatible with Apache Thais. Thais is like another system similar to Spark. Um, and you can also do a custom like MapReduce on through Hive. So basically, Hive is like your replacement for your SQL on RDBMS side, right? For Hadoop. Um, how uh, how Hive maintains all this metadata is basically underneath there is MySQL MySQL server. So basically, Hive stores all this metadata information on a MySQL engine underneath, and that's where all the table metadata and database metadatas are stored. And two components of Hive, the major components are like H catalog and web H catalog. So you might have come across this if you have worked on IE. You might have come across this H catalog. Um, at web catalog, we don't really explicitly call it, but underneath it is still using that. But H catalog, you might have seen it in Oozie workflow. I'll go through what is Oozie in some time. Uh, but basically, think of it as if like H catalog is a table. It's like a table and a storage management layer for Hadoop that enables like users with different data processing tools. Like you can use pig scripts. Some of you might have written pig scripts before we started working on Spark. Uh, but I don't think a lot of environments or companies do pig today. Pig is they say pig is kind of dying, but you can still use pig. It is still an active Apache project, or you can explicitly write MapReduce applications using Java. But again, nobody writes a MapReduce job. At least I haven't seen many people. I used to write MapReduce job when I initially started off on Hive back in 2010 or yeah, sometime then. But slowly, actually, we are stopping to use MapReduce as much. But underneath, know that we are still all the systems still perform MapReduce, although you don't write MapReduce problems because MapReduce is little complex programming concepts where you need to write a mapper separately and a reduce concept separately. If you have used Scala for Spark, you are still writing MapReduce like constructs, like we do data frame dot map, and you perform some operation on that data frame, and then you do a reduce to get that result set that you need, reduce by key or order by key and things like that. It's still a MapReduce concept, but you do it a little differently today than what we used to do a little like 5-10 years ago. So Hive supports different file formats. You might recognize some of them. We use Parquet, text file. You can. We don't use Avro. Avro is not directly supported. Avro and ORC. Um, Avro is not directly supported right now on Cloudera with the version that we have, but it will be supported soon. We are planning to upgrade our system. So once we go to Hive 2, where updates are supported, so I will talk about that in future sessions maybe. There is updates available now. Initially, Hadoop file system didn't have a lot of updates, but today we do have updates in some of the you know data stores like Hive 2.0 and above. They started introducing updates, and there is Cassandra. Cassandra actually uses Spark to perform all the computation underneath, and it provides updates too. Um, so these are some of the file storage file formats for Hive. All right. So fundamentally, like um, in Hive you can create two types of tables. One is, like I talked a little while ago, a managed table, which is an internal table. Another name is for managed table is internal, and an external table. So managed table is basically you're letting Hive to manage the life cycle um, of the life cycle of the data life cycle. So ideally, when you create a managed table, it is actually stored under this location, user Hive warehouse, on a on a by default. This is the location, and this is the database name, which database it belongs to, and then you have the table name, and then you will see the snappy compressed Parquet files. Parquet is like the recognized or the recommended file format because it works really well with the serialization and deserialization of data across the nodes. Basically, like for example, you can actually create an external table sitting on top of like a flat file, like a text or a CSV, without even having to process it, right? So you can create a table directly on a file, and you can run SQL-like queries. You can do that. I'll show that in few minutes here. But there is a problem with that. So it actually has affects your performance on the queries. So it's actually recommended always to use like Parquet as your storage format. It really helps with your uh, huge tables when you are actually using in Spark. Spark also uses Parquet for its serialization and deserialization. Actually Parquet works really well with data frames and data sets. So in manage table, like I said before, you let Hive manage the life cycle of the table, and when you drop a managed table, um, it actually deletes the underlying data of the table. You will lose the data. But in external table, in case of external table, actually it doesn't delete the underlying data. It basically deletes the table metadata from your Hive meta store. So it's actually not deleting the actual files underneath, unless you explicitly issue the purge command, which will purge the underlying data, right? So when you are deleting the actual table. Sorry, you had a question? Somebody had a question? Okay. So when you're using an external table, when you write a file or a data to that table, you have to perform this MSCK repair table action so that the Hive metastore actually recognize the newly available data or newly available partition to actually that's when the data shows up. So it doesn't show up until you perform this metadata refresh operation. So you might have seen emails come through from production saying, okay, I don't see the latest data loaded on the table. Okay, data is reflecting on Hive but not on Impala, and such kind of queries. So that is basically metadata not being refreshed. On Hive, you have to perform MSCK repair, which actually updates the metadata of underlying files. And on Impala, you have to perform invalidate metadata, which will do the same operation on Impala's side. Um, okay, here is an example of an external table and an internal table. So basically, let's, for example, I have a data set. I will go through that in a minute. So I have downloaded a sample data set for import and export trade data set. Basically, these are the columns. You can actually specify partitioning. So and here is the location. So even on internal table and external tables, you can actually specify the location. You can specify the path. If you see on internal table side, I haven't specified the location. I could still do that. I can override it. But like we saw earlier, by default, internal tables store data in this Hive warehouse location. So in this case, it will be stored under Hive warehouse location. But you can actually specify a location where you want the data to be stored. And a lot of our queries, you will see that we explicitly specify where the data should be stored. And you can actually like for example, this is an external table which is basically sitting on top of a CSV file. It uses a CSV, a SERDIF format to read the CSV file, and I'm just basically setting the table properties with, it's a comma separated file and it's quote enclosed, and the files reside in this location, and we are performing MSCK repair. So this refreshes the data, and you can start seeing the data on the.
So Vicky, a quick question.
Sure.
So we are using internal table approach, right?
No, we use a lot of external tables.
Okay.
Yeah.
So, but the ParQ cannot be used in external tables?
No, you can. So, like I mentioned before, there are different formats available, but our version of Hadoop that we have doesn't support some of the file formats. Right? We don't use, and some of the file formats we don't have a use case for. Um, we but we do use text file, CSV, Parquet. We use a lot of Parquet. We store all of our data in Parquet format. But you can specify Parquet here. When you specify Parquet here, it's not going to recognize your file as this SERDI format, so you'll have to load the data in Parquet format. We can go through that when we go through the examples of Spark, how to load data and how we load today.
Okay, thanks, Vicky.
Yeah. So you see there is on this side, on this external table side, I don't have partition created, but I have a partition block here. Partitions are basically, think of it like you create like sets of the group sets of data together, right? So I'm basically saying for this data set, group all the data or while loading the data to the table, group the data by year. So it's partitioned by the year. So all like 2019 data is stored under 2019 bucket, and 2018 data is stored under 2018 partition. So it basically improves the performance of your query. Let's say when I'm writing a query, that I want to just scan through 2019's worth of data. So I don't really need to look at 2018 data. So it really affects the performance on Hive side. How Hive actually performs the operation is, since it's MapReduce, it identifies the partition and it looks for the partition that you are looking for, and it ignores the rest of the file. So ideally, Hive is not doing a full table scan. Instead, it's just skipping to that particular partition and looking for the data in that partition. So it improves performance. So there is bucketing too. So within partitions, you can create bucketing. Let's say, for example, if I want to do within partition, I can, if I want to do, like say by month, so I can still have month as integer, right? So that's still, now I'm grouping by year, by month, and so on, if I had a column called month. So any questions so far?
So this partition column need not to be part of the table structure? I don't see that. Is that a typo mistake?
It is part of the table structure. So it is part of table, but you specify the partition columns in a partition block. That's it. So ideally, what happens is whatever column you put in partition blocks actually shows up in the last. You cannot order. You cannot have your partition column in the beginning, right? So you can, while I'm specifying year here, I cannot specify year here. So it's gonna throw a
Okay.
error. So all the partition columns will be at the end. So ideally what we do is, at least this is the recommended approach in my years of experience. Ideally, since Hive, at least in the future, we might have a lot of update support and it might get better, and there might be a lot of support in the future. But at least right now, since like writes and updates are very expensive operation, so Hive is append only. We do appends. Basically, you get every day's data and do an append to that table by the frequency of the data set. Like say, if it's monthly, you create monthly partition. If it's daily, you create daily partition, and so on. I will tell you why it is very important when we go through Oozie and how partitions or the dependency concepts really work using Oozie, and how Hive or Oozie uses success flags and partition flags to set the dependencies. So it's always recommended to just basically do partition by the frequency or the cadence of the data set. Any
Quick
more
question.
questions?
Yeah, quick question,
Yeah.
Vicky. So I've created a kind of a table and I partition based on the, say, for example, you have a year partition,
Mm-hmm.
right?
Mm-hmm.
So when I created a table and loaded some data, so which is around 2 gigs of data.
Mm-hmm.
So when you have a cluster of say 10 nodes and you have a block size of 124 MB.
Mm-hmm.
So does the how does the HD, I mean, how does it load in the on the HDFS cluster? So does it load based on your partition or does it just load based on your block size?
Yeah, so basically your files are split by partitions. So I will go through
Okay.
that in a minute when I show I haven't, let me bring up the, um, let's see, I wanted to do that in the last, but um, ideally, let me kick off the cluster while it's coming back on the background. So let's say you have a 1 gig, like you said, 1 gigs of file, which actually contains data of, let's say, 20 all the way from 2017, right? So 3 years worth of data. While it's storing to the table, since we partition by year, all 2017 data will go into uh, one partition. and then you have all 2018 data will go into one partition, and within that partition it will follow the you'll have to follow the block size concept, right? So let's say 2018 data was somewhere around um, 500 MB, right? So if your block size is 100 MB, you split the files into five chunks and then store the data in that partition. You understand what I'm saying?
Yeah, yeah,
Yeah.
got it.
So
Thanks.
basically, it's actually scanning through the blocks of data, and the blocks are replicated to other nodes. So you have multiple copies of the same data across the node.
So if the nodes are across the network, say, or it has to be like, um, I mean, so if the nodes are across the network, right? So how does it pick like which one is the so it is replicated across multiple nodes.
Yeah.
So I mean, how does it pick the I mean the or the nearest one or the
Yeah.
closest one to that name node?
Yeah. How does the job know where to find the
Yeah,
data? So
yeah.
let's say, for example, we have 10 node cluster, and then we have a replication factor set to 3. And so the file or the blocks are actually replicated across like 3 times on across like randomly, right?
Mhm, mhm.
And name node keeps track of which node has which data. So when you issue or a read request or a write request to that particular table, name node now basically tries to scan through its catalog to say, okay, this is the table and this is where the data lies, and this block or node 1 has these blocks of data. So node 2 has these blocks of data. So it'll try to, instead of going and taking that data and then bringing it to one node and doing the processing, basically name node assigns that node a task. Okay, you have this set of data, can you perform this operation for me, like this set of operation within your files? Can you give me the max in your file, in your blocks?